Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Natasha binti Limuncai alias Muhammad Hailin. Today I am going to present our paper which titled The Fixed Points of B-Bistochastic-Volterra Quadratic Stochastic Operator defined on S1 times S1. This presentation consists of introduction, objectives, literature review, methodology, results, and lastly, conclusion. Quadratic stochastic operator, or QSO, is the simplest nonlinear Markov operator, and it is not fully studied yet. QSO was first initiated by Bernstein, which is usually used to present the time evolution of species in biology. For example, let us consider set I to be the n-type of species in a population. Given the initial probability distribution of the species in a population denoted by x0, then we can find the probability distribution of the first generation by applying the QSO as total probability as shown here. Pijk is the probability of an individual where there exists cross-fertilization between an individual from I species and J species and then form an individual from K species. Since QSO is difficult to be studied in general, there are many researchers who introduce various classes of QSO such as strictly non-Volterra QSO, centered QSO, B-Stochastic QSO, B-Bistochastic QSO, and many more. However, all these classes still do not yet cover the whole set of QSO. Therefore, this paper introduces a new class of QSO named B-Bistochastic-Volterra QSO or bV-QSO defined on one-dimensional simplex, which is S1 times S1 and mapped to itself. The objectives of this paper includes to develop the form and conditions of bV-QSO on one-dimensional simplex, to list all of the fixed points and their stability on one-dimensional simplex, and to study the trajectories of bV-QSO defined on one-dimensional simplex. Next is literature review, which include B-Bistochastic and Volterra QSO, which is applied in this paper. In 1993, Kozov introduced B-Stochastic QSO in terms of classical majorization, where Vx is majorated by x for all x in Sn-1. In 1996, Parker and Ram introduced a new order called majorization to generalize the classical majorization under linear system. This majorization can also be defined as partial order on sequence. In 2015, Muhammadov and Mbong introduced a new class named B-Bistochastic QSO in terms of the new majorization, or simply called B-order. Next, for Volterra QSO, Kozov provided all necessary definitions and a brief description of the result in discrete time dynamical system generated by Volterra QSO in their paper. In 2011, Razikov and Zamilov described all of the fixed points of Volterra QSO of a two-sex population and constructed Lyapunov function in order to investigate their dynamical behavior. Next, this is the definition of B-Bistochastic QSO, where V is called B-Bistochastic QSO if Vx is B-ordered by x for all x in Sn-1. And the properties of Volterra QSO defined on Sn-1 times Sv-1 mapped to itself is include Pijk equals to 0 for any k not in Ij. Next is methodology. The methodology in this paper can be summarized into this framework, where we will start with literature review of B-Bistochastic QSO and Volterra QSO. Then, by applying the definition and the properties of B-Bistochastic and Volterra QSO, we develop the form of bV-QSO defined on one-dimensional simplex, which is S1 times S1 mapped to itself. Then we list all of the fixed points of bV-QSO defined on one-dimensional simplex and determine their stability by applying Jacobian matrix. Next, this is the definition of bV-QSO, where V is called bV-QSO if Vx is B ordered by X, and for Vy, the heredity coefficient is equals to 0 for male population. Next, this is the result, where the simplex used in this paper consists of x1 and x2, and it is non-negative, and the summation is equal to 1. So this is the form of bV-QSO defined on one-dimensional simplex, where A is equals to P111 for female population and B is equals to P121 for male population. This is some of the proof of the description of bV-QSO on one-dimensional simplex, where this is the equation, the general equation for QSO, and because of the stochasticity properties of x, where x1 plus x2 is equals to 1, we only considered x1 and y1 and substitute the value of y2 equals to 1 minus y1 and the same for x2. So this is the simplified equation. Next, from the definition of bV-QSO, we obtain this equation, where the equation is satisfied for any value of x and y from 0 to 1. So when we input any value of x and y from 0 to 1, we can obtain the value of Pijk for female population, while for male population, we obtain from the properties of Volterra QSO. Next, the theorem consists of the fixed point, where 0, 0, 0, y, 1, 1, and x1 are the fixed point for bV-QSO for this condition stated. Next, to determine the stability, we have 0, 0 is attracting fixed point for b less than 1, 0y implies non-hyperbolic fixed point, 1, 1 is a saddle fixed point for b less than 1, and lastly x1 implies non-hyperbolic fixed point. The fixed point obtained is to study the trajectories. Therefore, we consider this figure, which includes the shaded region and 4 sides, which is x1 equals to 0, y1 equals to 0, x2 equals to 1, and y2 equals to 1. Next, the Lyapunov function is constructed in order to study the trajectory of bV-QSO, where the Lyapunov function in here is x plus y, where for the condition of a plus b less than or equals to 1, and then we find the limit and obtain that for the condition a plus b less than 1, we have the limit for both x and y is equals to 0. Next, this is on the boundary on the side, where we for any initial point, we obtain the limit is converged. In conclusion, this paper introduces a new class of QSO, namely bV-QSO, defined on one-dimensional simplex. All the fixed points and their stabilities are presented in this paper. Since the operator converges for any initial point, therefore we concluded that bV-QSO defined on one-dimensional simplex is a regular operator. And the study of bV-QSO on two-dimensional simplex also has been done, which will be published in another work. And lastly, the study of bV-QSO on high-dimensional simplex remain as open problem. That's all from me. Thank you for listening.